Now, the next thing we'll try to understand the comparison between the different protocols which can be used with First Hop Redundancy Protocols. So if you remember, the First Hop Redundancy Protocols basically provide you the router redundancy where we can have multiple gateways. Like in this case, if you see here, we do have the router 1 acting as my primary gateway, and the router 3 will be acting as a secondary gateway. So we'll be doing the similar kind of setup as well. Now, the main difference between these three is the first one, HSRP, which is something most commonly we'll try to verify. The first one, it's a Cisco proprietary one. Cisco proprietary meaning it works with only Cisco devices, which means if you're implementing any Cisco specific network, like both the routers are running Cisco only, then you can use the HSRP to provide the redundancy between the two routers. Now, likewise, if you're using any non-Cisco environment, now the second one, the VRRP, which is an open standard defined in the RFC 3768. Basically, if you're running any multiple vendors, like maybe you're running a Cisco device on one side, maybe an HP router or any other vendor, you'll find generally like Cisco or Juniper routers, you can still run VRRP. So that's a VRRP. You know the difference between standard and the proprietary options. Now, the other option, the GLBP. GLBP is also a Cisco proprietary protocol, which basically supports redundancy at the same time supports load balancing. So if you compare these two, both are Cisco proprietary, but the major difference between the GLBP and the HSRP is you will see load balancing. We'll talk about the load balancing. Basically, here you can do load balancing. I'll just come to that. Okay. Now, the second option, you can have one active router. Now, typically, you will have two routers. One will be as a primary. Technically, we call it as an active standby. That's the technical names we call it as. One will be forwarding the traffic, whereas the other one is a standby, which is generally a backup. Here also, we can have one active, one standby, but whereas here we can have load balancing can be done. Now, load balancing means in the case of GLBP, we can have multiple gateways, like I can have up to 4, or these gateways all can send or forward the traffic simultaneously. So the main advantage of the GLBP is it will support load balancing where both the gateways can actively forward the traffic, like both are sending the traffic at the same time. Okay, so we can do some load sharing here. We'll talk about that later on. Again, more on the GLBP load sharing or the load balancing. I'll talk about that when we come to the GLBP configurations. Now, the third option, we have something like the virtual IP address. Now, what is virtual IP? Because whenever you know the ARP protocol, the address resolution protocol, whenever I'm sending a packet source from 192.168.1.1 from any one of the computer, and if it is destined to anything on the internet, let's say 202.1.1.1 somewhere on the internet, you know, there is an ARP protocol which will resolve IP to MAC. So there is an IP address. At the back end, there is a MAC address which will be resolved. So the source MAC address will be the MAC address of the PC, and the destination will be always the MAC address of the gateway. So in this case, the ARP resolution happens only within the LAN. So this will be the gateway MAC address. So when we configure the redundancy protocol, in this case, we're not using the physical gateways, we are using the virtual gateway. So which means it's going to create automatically the virtual MAC address also. Okay, so these MAC addresses can be automatically obtained, means generally we can either manually configure these virtual MAC addresses, or we can just leave it to the default, like it will automatically use this 00000C A7 AC, and the last two numbers will be based on the group number. So if I'm using group 1, then it will be 01 like that. So depending upon what we use, similar way here also. If I'm using group 5, then it will be 05. And finally, even the GLBP also, it will automatically derive the virtual MAC address. Okay, so it will do automatically, so we don't need to do anything. But still, if you want, you can manually. Basically, these virtual MAC addresses will be automatically obtained, but I think this is a virtual IP address which is manually configured. So basically, we have to configure one group address which will identify, and this group address will be from the same subnet. So these 200 and 200 are the physical interface address. And we have to identify, or we have to manually configure the group address, which is actually the IP address. Sorry. So the MAC address and IP address both are different things. So the IP address has to be manually configured during the configurations, whereas the MAC address, it will be automatically derived. Okay. Now the other options, there is something called preempt. Now, other comparisons like preempt. Now preempt is like uh, the first we need to understand what is preempt. Now preempt means, let's take an example. We have two gateways, let's say the router 1 and the router 3, and we decided that the router 1 is going to be the primary gateway. The primary gateway, or in case of HSRP terminology, we call it as an active router. So, and the second one will be the secondary. Secondary is nothing but the backup, or we call it as a standby. Standby is the terminology we use here in the case of secondary. So, which means the router 1 will be actively sending the traffic onto the internet, whereas the secondary is just a backup and it will not forward any traffic by default in general. So now what happens if the router 1 goes down? So let's say the router 1 goes down, automatically the HSRP or VRRP or GLBP, any of the protocols will automatically make this as a primary, and it will start forwarding the traffic from here. So which means when the router 1 goes down, the other gateway will automatically become active or primary, and start forwarding the traffic. Now, what happens if the router 1 is back? Now, maybe there is a small issue with the router, it just rebooted, or you replaced with a new router, or for time being the router 1 was down. So when the router 1 is back, the default behavior is non-preempt. So first we'll understand the non-preempt. Now non-preempt is just like your OSP of DR BDR, if you a little bit correlate that. When the primary is down, and the secondary will become the primary, and when the primary is back, it has to wait. So basically the non-preempt behavior is nothing but, now the router 1 is not going to become the primary even though it is up and running, because already the router 3 has become the primary. So if the router 1 has to become the primary, the router 3 has to go down. Let's say I have to go down, and then the router 1 will become the primary. So we call this behavior as a non-preempt, which is default in HSRP, non-preempt. But we can change to preempt. So there is a command we will be adding later on to change the behavior to preempt. Okay. Normally, in the case of, if you just compare, in the case of HSRP, by default, the preempt is disabled, which means the same thing, router 1 goes down, the router 3 become the primary. And if the router 1 is back, still the primary will be router 3. So you have to wait. So probably what I can do, I can enable this with a command called preempt. And again, in the case of VRRP, no need to give preempt, because by default the preemption is enabled, which means router 1 will be the primary as long as it is up and running. If it is going down, router 3 become the primary, and the router 1 is back up, again it will become the primary. So automatically it's just like, if I'm the manager or I'm the leader, if I'm not there, someone else will take up my role. But when I'm back, I'm going to take my role back. That's what preemption enable. Of course, here it is disabled, but we can enable it with a preempt command, which is something we'll do at the time of configurations as well. Now, the other options, even if you're using IPv6 networks in your network, so in the version 2, the HSRP, the IPv6 is supported. You can still run the same thing. Here, anyway, we'll be doing with IPv4, but if there is an IPv6, there is a support in version 2 in the case of HSRP. And the same way, if you're using VRRP, then you need to make sure that you're running version 3. And the GLBP also, there is a fully support IPv6. Okay. So as today's network, IPv6 becomes mandatory support for all the technologies, all the protocols. So it's supported here. Now, the other thing, the protocol. Now this HSRP, they talk to each other based on some port numbers. because just like these two, primary and secondary, they will talk to each other based on some port numbers. Like the HSRP uses 1985 port number UDP based, and here it is 112, and then these are the port numbers. Okay, so these ports are basically the ports, just like we have HTTP port number 80. Similar way, these protocol will talk to each other, or the different gateways talk to each other using these port numbers, like sending the hello messages between them, or advertising the packets between the routers. This kind of information will be exchanged. So whenever you are writing, let's say if you're writing any specific ACLs, now we need to remember this port number, especially when you're writing ACLs. There might be a possibility that if you have any ACL, that ACL might be denying this particular port numbers, then it will impact the communication for this protocol. So we need to make sure that if I'm running HSRP, we need to make sure that this particular traffic is permitted. And if you're using VRRP, then this particular port should be permitted. If I'm using GLBP, then that particular port should be permitted. So most of the time, we don't need to really worry about these ports. But if you're writing any ACLs on the LAN interface, we need to make sure that ACL is not dropping this particular protocol traffic. So probably at the time of troubleshooting, that's something we need to look out for. Now, the other option, there is something called timers. Now, what is timers? Timers are like hellos. The router 1 will be sending a hello to router 3 for every 3 seconds. The hello timer for every 3 seconds in the case of HSRP, which means constantly both the gateways will be exchanging the hellos with each other uh, for checking whether both the devices are available there or not. Just like if you know the OSP of neighborship, there is a hello packet sent for every 10 seconds, basically to check whether the neighbor is up and running or not. The same thing in HSRP here also. The gateways has to know each other. They send and receive the hellos. And if I'm not receiving any hello for 10 seconds, it will immediately, like let's say the router 1 goes down and there will be no hellos are exchanged. The hellos will be exchanged through this LAN interface. And if there is no hellos are exchanged, then immediately after 10 seconds, it's going to start the convergence, which means if there is no hello packet received in 10 seconds, the failover occurs. Failover means switching over to the other gateway. Now, likewise, the same thing in GLBP, also the same timers, no difference, because the HSRP, GLBP are more like from the same Cisco, so you will have similarities, except the default load balancing. And whereas in the VRRP, there is a slight difference. Like for every 1 second, there is a hello, which is generally taken. And then, if the master is down, then it's going to take 3 times of advertisements, plus there is an additional time. So there is a little bit of calculation where it will take 1 second for the advertisement interval. And if there is any failover happens, so probably it will take around 3 seconds time generally if there is no advertisements are received. So overall, it is like around 3 seconds. So there is a skew time. There's a backend calculation. Roughly, you can count it as 1 and 3. That's how the timer. So in terms of VRRP looks faster convergence. But of course, I can change these hellos. If you want, we can make the GLBP or the HSRP also, we can change the hellos. That's something we'll see how to change in the configuration. So if we see the failover time, like the failover time is the maximum of 10 seconds, whereas here around 3 seconds and here around 10 seconds, it will take for the other gateway or the second gateway to become the primary and start forwarding the traffic. So which means roughly 10 seconds of downtime, which is very less, and the end user will never come to know this downtime. If he's trying to access any browser or internet, and maybe he will not get the web page by the time he refresh couple of times, then or try to open other web pages, by the time it will come up automatically switching over the gateways. Okay, so mostly you change these timers if you are running any critical network where you want a faster failover, we can change the timers. Now, other options, we have authentication. Now, authentication is basically where you can configure the gateways with the passwords on both the sides, and both the routers will form a group or become a virtual gateway group only if they successfully have authentication matching on both the sides. Okay. So this is basically to prevent any unauthorized routers, because there is a possibility that someone or by mistake add one router and advertise itself as a primary, and there is a possibility that all your traffic to the internet might route to a different gateway, which is something not possible in most cases. Normally, no one will do that. But let's take an example. That something, a possibility is there where there is someone sitting on the network who is having some basic access to the network, might be adding the router, or maybe there is already a router connected. Unauthorized router may end up advertising itself as a primary, and it can impact the performance. So we don't want that kind of issues. Just to prevent that, it's recommended to configure authentication. Configuration we'll see as we get into that. Now, the other option, there is something called priority configuration. Now, what is priority? Now, priority comes important where if you have two gateways, like in this example, let's say this is my ISP1 connection, which is a 50 Mbps link, and I'm taking a second ISP connection, which is typically like 2 Mbps link. Now, whenever you take two ISP connections, most of the time the secondary ISP will be lesser bandwidth, because most of the time, as you know, this will be an active and sending the traffic, and the second link will be only utilized when the primary goes down. Normally, if you are not doing load balancing or load sharing, that's a normal scenario. Now, in this scenario, I want to make sure that this should be the active. So what I'll do is the default priority value will be 100. So by default, the elections will occur based on the priority value. So whichever the device is having the highest priority value, that will automatically become the primary. Now the default priority value will be 100 in all the three. So when you have the default priority value of 100, or when there is a tie in the priority value, the tiebreaker will be the highest IP address. Which means here you can see it is a 192.168.1.100, and this is 192.168.1.200. Automatically, this is likely to become the primary, which is something I don't want. So I don't want my 2 Mbps link to become the primary, and I always want my 50 Mbps link to be the primary. So what I can do, I can just simply go and change the priority value, something higher than 100, which is something can be configured in all the three cases. We can decide which gateway is going to become the primary. So what if I'm using both the same Mbps? So in that case, there's no need to worry. Whoever becomes the primary, doesn't matter, which is something not required. But most of the time, if you want to decide who is going to become the primary, we can configure the priority value to make sure that your high-speed link to become the primary. Now, the next step, that's based on the election. Okay, so the elections are done based on the priority value. If there's a tiebreaker, or if there is a same priority value, then the tiebreaker will be the highest IP address. Now, one more thing, the HSRP, they use some hello messages. So the hello messages will be using the multicast address, just like OSPF hellos. They use a multicast address like 224.0.0.2, 18, and 102. These are the reserved multicast addresses used by the routers to exchange any packets relating to this protocol. So the communication between them, they use these multicast addresses to identify the actual protocol traffic. Of course, there is a UDP port numbers also I discussed, that is to identify the traffic as the packets travels in your LAN. Now, like I said, the router roles, we can have one primary. Now, in this case, HSRP, we can have one active. Active means actively forwarding the traffic. The other one will be the standby, nothing but the backup. It will not forward any traffic. Only active will forward the traffic. And if the active goes down, then only the standby will become the active and it will start forwarding the traffic. The same thing here as well. Here also the same thing. But you can have more than one backup router. So here in the case of HSRP, we can have only two. One will be active, other one will be standby. In the case of VRRP, we can have one active and we can have more than one as a backup or standby. We can have more than one. Normally, you don't do it. Normally, having 3 connections is going to be very big. You don't want that. But in the case of VRRP, we can have more than one backup router. Whereas in the case of GLBP, we can use load balancing. So the main advantage of GLBP compared to these two is the load balancing. Now we see the load balancing is not possible here. Now what's the meaning of load balancing? So if you just take an example here, we are going to go with 2 gateways. One gateway will be actively forwarding the traffic. The other one will be the standby, which means any one gateway will be forwarding the traffic at once time. So this is more applicable with the first two protocols, whether it is HSRP or the VRRP protocols. But whereas if you take the GLBP, now in the GLBP, we can have up to 4 gateways. Okay, so 4 gateways we can add up to maximum of 4. And all the gateways will be forwarding the traffic, can forward the traffic at the same time. And there are some technical terminologies called AVF, AVG. We'll talk about that when we get into the individual protocols. So I'm not getting into that right now. So basically, the main advantage of using the GLBP is to do the load balancing. Okay, that's what mainly it supports. And the load balancing mechanism also, we'll talk about that in the GLBP section. We don't get into that right now because before that, we need to understand a little bit on practically we'll need to implement. That's what we'll do first. Now, finally, there is one more point I would like to add. There's something called use case. Use case is like, now you will ask me, okay, where and when I'll be using, which one I should prefer. So typically, if you're going with a new setup, you always go with GLBP. And if you want to support the load balancing at the same time, if you're implementing the Cisco products, and if you have more than one gateway, typically you always go with a GLBP. Okay, so if you're using a Cisco environment or if you're using any old environment, you still see HSRP implemented in most of the environments where I have seen they just have the HSRP already running and you don't want to disturb. Even though they don't support load balancing, we can do load sharing. So load sharing is possible. Like one VLAN using this gateway, another VLAN this gateway. I'll show you with a lab configuration a little bit later. But even though it doesn't support the load balancing, we can do some kind of load sharing, which is most of the people in today using this load sharing concept with HSRP. That's something what you may see in the production scenarios, or you might be using GLBP, or you might be using VRRP. So basically, all the three will do the same job for you. And there's no much difference in terms of behavior. Of course, there are a few differences what we have seen. Load balancing basically it depends on that. So if you're using any cross vendor boundaries, if you're using any kind of Cisco and a non-Cisco environment or any Juniper routers instead of Cisco, because typically if you're using non-Cisco environment, you cannot use any of these two. You probably go with VRRP. Okay, so like mixed network. So any one you have to use at that. Okay, so it all depends. If you want to go load balancing, I generally always go with a GLBP. If it is a new configurations, if it is an older configurations running HSRP, I might go with HSRP. But if there is an option to upgrade to GLBP, I'll try to upgrade that. Okay. So these are some of the options or the comparisons. Very important to know, especially when you are facing interviews or understanding the behaviors. Probably these differences will help you out to differentiate these things. Like the job is same. You might be using anyone, just like OSPF or EHRP, you might be using anyone. Similar way here also, you will be using any one of the protocols in the production network.